Thank you. All right, cool. So my name's Blas, and I work at Chargify.com. And Chargify is a site that provides a service for managing recurring subscription billing, like with credit cards and everything that goes along with that. Stuff like expiration dates on credit cards and renewals and coupons and just everything that goes along with that. And last year, we decided that we wanted to move data centers, and we picked a new data center and needed to move all of our operations from the old data center to the new one. And the thing about Chargify is that we help process money for other businesses. And despite what a lot of young startups may think, a business is around to make money. It's got to make money for somebody, or else it goes away. No money, no business, right? So if we're not processing the signups and the transactions for the people who rely upon us, suddenly they're no longer making money, and that's a really fast way to have a very unhappy customer. So that means we don't have any planned outages. We don't have maintenance windows. We basically aim to be up 24/7, 100% uptime. Obviously, it's not possible, but that's our goal, and anything less than that, we don't like. But we had to switch. So we went on this crusade to find a new provider, and I'm going to skip the track a little bit and talk about our search for a new provider, because it's a really key part of how we executed the migration the way we did. And to start with it, I'm going to say I really hate sales when it comes to enterprise sales. So we have the unique requirement of being a level 1 PCI, required to be level 1 PCI compliant. And so we have to look for a data center or a hosting provider who is able to be there alongside us and meet the same requirements that we have to meet. And that presents a lot of problems. Basically, you wind up with two extremes. You wind up with a lot of old guard data centers who work like it's still 1980, who want to ask you questions like, what kind of servers are you going to need 3 years from now? To make these kind of grand predictions, to do this whole bid process where you have to do evaluations and you have to do all sorts of things in order to even figure out if they're going to let you buy from them, right? It's really ridiculous. I'm sure everybody has some experience with that. And the other thing is they're going to come up with a price. You're going to tell them what you want based on magically pulling system specs out of your head, and then they're going to go to this book. Anybody know what this book is? Anybody ever seen one of these? It's almost log tables. It is a book of random numbers. That's what it is. They used to print books full of random numbers. These are high entropy numbers, and they'll go and they'll pick one, and that's the price they're going to give you, right? There's discounts, and there's 20 pages of pricing sheets, and oh, it's the second Tuesday after Labor Day, so you're going to have to pay an extra 5% and all these kind of things, and they come up with a number. It drives me up a wall. So instead we picked EC2. The other end of the spectrum, the quintessential cloud provider, the start of the cloud virtualization revolution. And they also happen to be a certified level 1 PCI provider. And not a lot of other cloud providers are competing in that space yet. They want to be. A lot of them are working really hard. Some of them are there. Some of them are better than others. But when it comes to looking for the type of flexibility that any agile business that we all deal with wants, these guys are still the 800-pound gorilla. And they have the expertise in being a level 1 PCI provider. And so that was kind of one of the big things. It was like either get stuck in the old model, which was the model we were trying to leave. That's what we were trying to get away from. the guys who we would have to call up, even though we already had an account and already had dozens of servers, we'd have to call up a sales guy, and he'd have to talk with his boss and get a special quote if we wanted an extra virtual machine, right? So we wanted away from that. And so we said, okay, Amazon's not perfect, you know, they've got their warts and all, but they have been around longer than any other cloud provider. They meet our security requirements. They offer support. It used to be they didn't offer support, right? But they do offer like an enterprise class support right now. And if anybody here has experience with it, I think they'll probably tell you the same thing I would, which is that it's really, really good. It's the type of support where you call or you get on a live chat, and the very first person you talk to is the guy who knows exactly how to do what you need to do. There's no jumping, there's no transferring to 6 different people. You can get talking to somebody who has the power to do what you want the first time. And that makes us for a happy customer. So we chose EC2. And we came up with this grand plan for how we're going to move. And it started with adding automation. So we were moving away from the old guard. We were leaving an environment where the hands-on manager of our environment were doing hand scripts and hand commands in the bash shell to configure the systems and keep them up and running and do maintenance on them and all these other things. And so obviously, number one is we had to get it automated. And we picked Chef. Puppet's great too. We picked Chef because we're a Ruby shop, and we had to put that into our old data center. There was no way to prove if we were to go and just build all our new systems with Chef that they matched the old ones unless the old ones were under the control of Chef too. So we had to put Chef on the old systems first. Once we did that, we could take an entire copy of our stack top to bottom, put it in Amazon, and then run them side by side in what is basically like a disaster recovery hot spare type of scenario. And then one day, all we have to do is say, well, let's fail over to it just as if our old provider was disappearing. But instead of being an unplanned outage, it was a planned failover. And then the goal is to minimize how much downtime is in that failover window. Ideally, we want none whatsoever. And then all we have to do is try it again and again until it works in our test environment, of course, not our real environment. And one day we're happy enough with it and we pull the trigger on the real thing. So with that, I'm gonna go and talk about the testing real quick, because testing can mean a lot of different things. We've got our unit tests for our application and controller tests and stuff like that. And so there's that kind of testing. And then there's infrastructure testing, right? You put your Chef code in a repository and you version control that too, and you have some sort of testing for your Chef recipes, whether it brings up Vagrant or whatever and does a configuration and then checks to make sure that it really built a system that works like you would expect it to. So there's that kind of testing. And then there's a third kind of testing. And this is when I say test, and I'm going to say test a lot throughout this presentation, but when I say test, I'm talking about this third kind, and this third kind is what I would call process testing. This is the chaos monkey type of stuff. This is you've got all these interconnected pieces talking to one another, and you need to be able to prove that they're accomplishing what they're supposed to be accomplishing. So it's kind of like integration testing, but it's at an even higher level. This is things like, is your site accepting a sign up and then sending an email back to the user? And the only way to really prove that is to have either somebody click through and do a sign up and then check their email, or have a script that replicates that. But top to bottom, your entire stack in production, is it doing exactly what you would expect it to be doing? And if you have that type of testing, then you can create a copy. You can check to see if the copy works exactly the same way, and then you can say, yes, these really are identical, and if I switched over tomorrow, everything would work the same. So that's what you have to have. That's the type of testing I'm talking about, is process level testing, integration testing, but don't confuse that with like Rails integration testing. All right, so we have this complete copy on both sides, the old data center and the new data center. We exercise everything, we test that all the things we would expect to happen are happening, our emails getting sent out, our requests coming from the right IPs, are our queues working, our jobs getting processed, our cron jobs running, all these kind of things. And then on top of that, you can generate fake traffic against it, right? There's lots of ways to do this. You can capture some live traffic and replay it. We thought about that for a while. It's got a lot of weird implications when your live traffic has credit card numbers in it. But we can generate fake traffic that generally matched what was going on, as long as it was exercising everything, every component that we had. Is it exercising email? Is it exercising queues? Is it, doing all the things that we've written? Is it hitting all the different pieces? And if we can generate some fake traffic, then we can do cool things like ramping that fake traffic way up. What happens when it's triple what we currently have? And that gives you a lot of flexibility. So it's really a nice thing to have, and it should definitely be a part, regardless of whether you're doing a migration or not. This is good stuff to have all the time. And so with all of that testing, then you need to be able to know whether it's working, and if it's not working, where are the problems, and that's where logging, alerting, those types of things come from. And typically that's like a separate set of logging, right? That's things like your scripts could be trying to sign up on your site every 5 minutes on a test site, and if suddenly your test site is no longer accepting signups, that can generate an alert, and then people can say, okay, well let's figure out what's wrong. All right, so now back onto the plan. Review the plan again. Here it was. Number one is introduce Chef into our old data center, and so we got to automate everything. I don't think I need to go into a lot of depth about why. Everybody knows that it's good, and why it's good, reproducible, version controlled, less human error, all that kind of stuff. It's a challenge. If you have an environment that's entirely, that has been managed by hand from previously, now you've got to get Chef running in it, and Chef's a complex thing. One cookbook has a dependency on 10 other cookbooks, and you can't just assume that it's going to be compatible with what you've already got, and it's a slog. It's just like if you had an application that had no tests, and you said, okay, we're going to get to 100% test coverage, and how are you going to do that? And well, it takes time, and it's little by little, right? So you write one cookbook, and hopefully with no dependencies. It helps if you start kind of at the root of the dependency tree. Things like setting up users needs to happen before you can set up your application, and you have to have an Apache recipe before you can have an application recipe and things like that. You kind of got to think about it, do it in the right order. Helps a lot. And we also had some unique challenges because our old environment was Red Hat and our new environment was Ubuntu. As much as Chef itself is very good at handling that situation. You can write a recipe, and with a couple of smart switches in a couple of places, you can write it so that it's compatible with both of them. But not every cookbook that's in the community repository is built that way, right? So some of them needed a little tuning. Eventually, we got through it, and all our old systems are now running on Chef, and then we turn around and we make a copy of them all, and then we've got a copy of everything in the new environment. And so then we get to how do we switch it over. And the theory is the typical share nothing architecture that we all strive for. If it was truly 100% share nothing, like if you just had static HTML files, you could have the old servers and the new servers, and you could run them both at once, and it wouldn't matter, and then one day you just shut down the old ones, and nobody knows the difference, right? So that's the ideal world that we want to live in. And the closer you get to that, the better off you are. All right, so before, where we've got both of them coming, and then we just kick one off, and that's all there is to it. But we don't live in that perfect world, right? There's some kind of synchronization at the data layer typically that goes on. And of course there's lots of ancillary little pieces that get in the way of that as well, and so we have to address those. And the first step for us, I'll get to what the pieces are, but the first step was how do we transfer data back and forth? If we're going to have these two sides communicating, and the answer is a VPN. So on the old data center side, we already had a actual hardware VPN appliance because that's how we log into the systems remotely and do all our work and everything like that. And Amazon has the wonderful capability of interconnecting with that. And so we were able to do a mashup of connecting those together and generating a VPN tunnel to do site-to-site VPN. And then all the systems think they're on the same network and they can talk to each other. You can basically send all your data back and forth without too much trouble. And as long as you think about it and make sure you're understanding the latency implications, it's certainly a big help. And not terribly complicated, with the exception of actually figuring out how to route the traffic for site-to-site communication. And that's where the beauty of VPC comes in. So VPC is Amazon's virtual private cloud, and it is, they kind of did an announcement. I talked to some of the guys back in November, and they're moving basically everybody in the direction of VPC. They made an announcement not too long ago that it's going to be kind of seamless behind-the-scenes default, so that if you started a whole new Amazon account nowadays, and you'll get a VPC and you'll be in a VPC even though you don't know it. So that's what they're moving towards. And so what it is it's basically your own private little network. In the previous, before VPC, every system that you get in Amazon EC2 was like routable to every other system. It had like a private IP address, and you'd launch a couple of them, and they could talk to each other. And if you had a buddy on a totally different account, they could talk to each other too, and you could put traffic back and forth, and it would stay in the data center, but there was really nothing else between you except that and the security groups. Now there's a new layer, which is actual network controls. So it's things like subnets. Sorry, I'm going to stay on this slide. It's things like you can set up your own subnets, you can define your own private IPs, you can set up routing tables. So this does awesome things like with the VPN, we can say, hey, any traffic destined for 10.2, put it all onto one machine, point it towards this machine, and this machine will forward it off into the ether somewhere. In our case, it was across the VPN tunnel, and you can route all your traffic like that. And you can set up network rules like this subnet can't talk to this other subnet, and so you can segregate your network. And you can do all these sorts of things that regular network engineers do, and I can pretend like I'm a real network engineer even though I'm not. That's what VPC offers. And so it's very powerful. It's also very complicated. You have to spend a lot of time reading the documentation, playing it with it, and everything like that. But if you're trying to play like a real data center, that's what you need to use. So now with all that out of the way, we'll talk about what were our actual pain points in the migration. And there were three big ones. There's DNS, there's Redis, which was one of our data stores, and MySQL, which was our other data store. So these were the pieces that generally needed to synchronize with everything else that was going on. So the DNS trouble, this one's an obvious one. If we're going to change our DNS to point from the old data center to the new data center, which we've got to do at some point, we've got to make a change to our DNS, and those changes aren't instant. They're not even predictable. Okay, they're incredibly error prone. Anybody who's ever had to say, well, just wait for DNS to propagate, there you go. So what that means is that we can't guarantee stopping traffic to one data center unless we just wanted to drop it altogether. And as we talked about, dropping the traffic altogether just isn't an option. And if you just accept that it's not an option, you've got to find a way around it. So we came up with the solution, and the solution was really very simple. We were going to take all of our app servers on the old data center and turn them off, and instead replace them with running versions of HA proxy and just forward all the traffic over the VPN. And it's secure over the VPN. It's an SSL connection anyway, and it's transparent to the end user. Since we have the certificate ourselves, we can just terminate the same SSL multiple times and nobody knows. Like we're doing our own little man in the middle, so to speak. And it adds round trip time. It makes your request slower. If the request has to go from Kansas City to Oregon as an extra hop, especially if it already came from Oregon and now it's gone across the country and back again for no reason, but a little bit of a longer request, just like Taylor was saying earlier, like, yeah, it's going to slow things down, but hey, an extra 500 milliseconds on the request is better than losing it. So that's pretty obvious for that. So then let's talk about Redis and Resque. So that's what we use Redis for, is Resque. And Redis failover is hard. There's Redis Sentinel. I don't know if you guys have read the docs for Redis Sentinel. It's something like 30 pages of state machine description. It's, okay, Redis Sentinel can be in one of 8 different states during which it'll follow this set of 20 different rules one by one until it comes to a conclusion, and so on and so forth. I can't understand what it does. It does work. I've gotten it working, but you know, this was like a year-long process for us, and Redis Sentinel wasn't even out when it started. So there's options out there. We weren't happy with it. We didn't have an alternative on how to synchronously move all traffic from one Redis instance to another to do like a failover that we could conclusively prove wasn't going to lose data and accidentally fail to enqueue an email that was supposed to go out or something like that. And so that was the problem we were facing with Redis. I think a lot of people probably face it. It's like the early days of MySQL, right? You've got like this master slave, and that's all great, except when you actually need to use the slave. And then all of a sudden, there's lots of problems. So our solution was to kind of take a step back and think about, we're using it for queues. And so what is a queue really? Well, we didn't actually have to synchronize them. We could have more than one of the same queue. And we could put jobs into both queues at once. And we could consume jobs from both queues at once. It doesn't matter, right? Like maybe somebody's email got out faster than it would have otherwise. The ordering doesn't even actually matter. We just need to make sure we did all the work that needs to be done. So we said, okay, on one data center, it's going to go to one Resque queue, and on the new data center, it's going to go to a totally different Redis instance with totally different Resque queue, and there you go. And then once the old queue is empty, the old queue could stay living long after the switchover until we're satisfied. We work it all off and it's empty, and then we get rid of it. So this was kind of a, we didn't really solve the problem. We just came up with a new problem that was easier to solve. So, and then the third one, the big one, this is the one that everybody wonders about, I think, is whether it's MySQL or whether it's Postgres, whatever the case may be, how do you deal with this? You've got a master in one data center and you've got a slave in another, and how do you reroute your traffic to it with guarantees for your data operations? And the answer is, it's of course really, really hard. So the first one is, we could go in a master-master sort of situation, which has a lot of, we all know the issues that are associated with that, the synchronizing the data across, 300 milliseconds of round trip ping time is going to slow everything way, way down. There's lots of other problems. It introduces reliability concerns and everything like that. And it wasn't a route that really made sense. I don't even think it was doable. Taylor basically said the same thing with regards to synchronous data. So we're going asynchronous on the replication, and then how do we switch everybody over? And our solution was to pay a lot of money, to buy a product called Continuant Tungsten. And Continuant Tungsten is a software package. It's partially like open source and free, and then there's licensing for a lot of the more advanced features. And it takes care of a lot of these things for us. And I mean, it's straightforward as far as enterprise licensing is concerned. It's just like buying support from Percona or 10gen or something like that, except these guys have come up with a product that takes over the responsibility for MySQL replication. You actually turn off regular MySQL replication, and it does its own set of replication. It has like globally unique statement IDs, which is out in MySQL 5.6 now and has been in Postgres for a while. But these guys have had it for quite a bit longer. Global replication statement IDs, and it has a cluster manager. So it basically has a topology where it decides, it comes up with a quorum on deciding who is the master, and if there's a failover, choosing a slave, redirecting all the traffic to it, and everything like that. And the cool part about it is it actually understands SQL, and so it takes in your SQL statements, and then it holds them. And it says, okay, if we're in the middle of a failover, we can hold all of your MySQL, your SQL commands, and wait for the failover to finish, and then release them. And it's doing a lot of the same. Oh, my pictures are broken. Okay, well that picture wasn't really important anyway. All right, so it's also data center aware. So it's got, it understands that you've got a data center versus another data center, and it understands localized affinity and the difference between how to fail over to a local replica, a local slave that isn't behind at all versus one that's 3 seconds behind and everything like that. They've solved a lot of the hard problems, and they did it by this whole concept of like stopping your SQL and then doing the switchover and then releasing it, and all that happens is your requests take a little bit longer, but nothing gets lost. Funny, my slides also said, go check out MySQL role swap and intermission, which would be basically doing the same thing, except intermission does it at like the HTTP request layer for holding all of your requests, and Tungsten's doing it at the SQL level. So there's some interesting things there. So that's how we solved that problem. And it's a really cool product. It allows us to do all of the things that like Taylor talked about. We can swap back and forth between our master and any number of slaves. We do so on a regular basis and without losing a single query in the process. And so we can flip them back and forth. We can take one offline, do updates, restart it. We can do schema changes to the slave and then bring it up as a master. And so we can do a manual version of PT online schema change, but it helps that by taking the system totally offline, a lot of schema changes for us go a lot faster than with PT online schema change because it's not happening live on the server as it's being used for traffic. So lots of cool things there. So we come to the big day. Oh, we have a question. Well, the whole processing things twice is something you have to solve even if you're not stopping the query. But the short answer is no. As far as how much slower it is, it's just like if the MySQL server was under heavy load and like it wasn't responding right away. Like the connection's just held, and you send in your SQL query and you wait some amount of time and then it comes back. It's like if it was a slow query, except they're all a lot slower. How slow depends on how far behind the slave was. So like if a slave is 2 seconds behind before doing a switchover, we've got to wait for the slave to catch up before sending traffic to it. And so it can depend on a lot of factors. It can be a couple of seconds. And in that period of time, all your requests are just kind of held and waiting. As long as your timeout isn't super low, all of our web services and stuff, they just sit there and they wait, and eventually the query comes back and they go on with their day. And it's just like it was a slow request. All right, So we come to the big day, we decide, okay, we've tested everything and we're gonna make the switch, and what kind of prep do we need to do? We need to lower the DNS TTL down to 5 minutes and test. We had a copy of everything, and we basically just flipped back and forth over and over and over again while doing all this simulated traffic until eventually one day, and every time we do that, we'd have a problem. Like something would go wrong, the data would desynchronize, or we'd lose something. We'd get error reports saying that requests were returned with an error code that should have been successful, and we'd investigate why and figure it out until eventually one day we were able to switch back and forth and on the test environment, and we weren't causing any errors. And so we said, okay, well, it must be good now. So what are you gonna do? So we came out with this plan. There's 6 steps, and that's kind of a lot of steps, right? Like the whole thing with automation is you're supposed to be able to do a single command for anything, right? That's kind of the mindset that everybody always has, is it should be a single command because that's the least error prone. What we came up with were a couple of steps, each of which were basically a single command, and we used them as stopping points in order to be able to deal with any issues that might come up in a safe manner. It's all well and good until your automated process dies in the middle, and then you're desperately trying to figure out why. So these gave us rollback points. And I'm going to go through them real quick. We stopped all non-essential processes just because less things working at once, less errors, potential for errors. So we stopped a whole bunch of stuff. And then we did this 3-phase thing, steps 2, 3, 4. I'm going to go through them quick. Here's what it looked like beforehand. Old data center, new data center, everything like I've just talked about, and we switched the master database to the new data center. And what happens is very high load. All of the queries are now going across the VPN to talk to the master on the other side of the country, and every one of those has 300 milliseconds extra on them. I mean, if your page has 10 queries to do 10 different active record fetches or whatever, then that was 10 round trips. And so there's a heavy amount of load there, and that's something we knew, we acknowledged, we said, well, it's okay because 2 seconds after we do that step, we're gonna do the very next step, which is to turn on HA proxy, and now we're just at a single round trip. So now the requests are being proxied through, and there's a single round trip. We did it this way instead of vice versa because the database switchover is still the most complex part, the most likely for something to go wrong, even though we'd done it a whole bunch and we were doing fine. But this way, if something went wrong with the database part of it, since it was the very first step, we had nothing else to roll back. We rolled back that one step, go back to our previous master, and we were, at least out of the woods until we figured out what was wrong. So we did that first and accepted the slowness for a couple of seconds. And then we've got this proxying, and then we switched the DNS. And so now most of the people are going to the new stuff. There's a couple of residual people going to the old stuff. This is the whole problem we were trying to solve to begin with. And eventually, nobody's hitting the old stuff anymore, and we can get rid of it. We waited a couple days or whatever and made sure that there were no requests in the last 24 hours or something. And then we can start out all the non-essential processes, and then clear out that old queue. So the queues weren't talking to each other in any fashion. So we've got an old queue and a new queue. We just work them both off, and we're good to go. All right, so what's next is we did a lot of work for this, and it's not all lost. We've been having so many dividends paid in the legwork that we did to make our infrastructure provable, to make it reliable, to make it handle these types of failures. We're now comfortable in switching to other data centers a lot more often. Obviously, it's not something we want to do very often, but we know it can be done, and it becomes a tool in your toolbox, and so that's really good, and we can continue doing test failovers and everything like that. And we would definitely want to do more elaborate load testing. So this would actually be high load levels of, like I said, capturing real live traffic and then replaying it against the servers is something I think is really cool. And we still may want to do that eventually. And the other is doing synchronized configuration with something like Zookeeper or Doozer. Makes a lot of the changes, like which Redis server you're supposed to talk to. Making those kind of changes easier than having to wait for Chef to run on everything. And test everything, document everything, and think through everything, and that's all there is to it. Yes.